Welcome each one of you to my YouTube channel Truly AI. Today we discuss about the concept of deep learning, a subset of machine learning. Hello, let me introduce myself. I am Neuron. You found my name a little misleading, difficult. You can call me as mini chef. My responsibility in this kitchen is to the role of a chef, but not in a big large extent, very small limited fashion. But at the same time, I have my own choices, my own priorities, my own selection procedures. Suppose here I have been given with these ingredients. Therefore, I may choose, say, 2 pieces of bread. What? 2 pieces of bread. I take, say, 3 pieces of cucumber, say 3 pieces, and I take 2 pieces of tomato, like that. That means corresponding to every ingredient, we have some number attached with that. 2 bread pieces, 3 cucumber, 2 tomato. Then these numbers 2, 3 and 2 are called the weights or my choices or my purities. I try to look at it, I simply taste it, and if I feel it is good, I just hand over to my friend. Again, a mini chef, another version of me, another neuron. This is what exactly a deep learning consists of. Collection of huge number of such small computing devices. Each is called a neuron because deep learning is inspired by the biological neural network. Our brain consists of millions of small devices called neurons. The task of each neuron is very simple. Receive signals from surrounding neurons, provide some weights attached with that, do some processing and give this signal to the next neuron. And that process is said to be activation. This is what exactly we have done in the case of these ingredients. We have different signals in the form of different ingredients. We have provided some weightage to that by taking that many pieces, 2 bread, 3 cucumber pieces, 2 tomato, etc. and combined it, processed it, and we activated in the sense that given to the next neuron. Similarly, we can have huge number of such mini chefs in this kitchen, and all these mini chefs working together providing, say, a sandwich at the end, and that is exactly a deep learning neural network style of working. I am in a deep kitchen now. What I meant by deep kitchen? Just like me being a mini chef, we have thousands of such mini chefs. What is the responsibility of each of the mini chefs? That's very simple task. All these mini chefs are arranged in a very nice fashion, what we call arranged in layers. Here we have, suppose, first layer of mini chefs, second layer of mini chef, third layer of mini chef, etc. Layers of mini chefs working in a very structured, very organized fashion. Let us see what exactly the mini chefs in the first layer does. Remember, the first layer comes with collecting the ingredients and looking at it and giving some weight to that, correspondingly joining that ingredients with the corresponding weights. For example, 2 pieces of bread loaves, 1 piece of tomato, 2 pieces of cucumber, etc. Taste it and give that to the information to the next neuron. Another neuron in the same layer will have similar idea, but that mini chef being an entirely new person, his likes, his tastes, his choices are different, therefore corresponding weights are different. He may be choosing, say, only one piece of bread, say 2 pieces of cucumber, 1 piece of tomato, etc. He processes that, tastes it, and gives that information to the next neuron. Similarly, suppose the first layer consists of a number of such neurons. Each of the neuron does very simple task: collect the ingredients, provide some weights, process it, taste it, and gives that information to the next one. This is exactly what happens in our biological neural network also. Once these thousands of such neurons in the first layer gives the information to the next layer, even in that layer there are thousands of such neurons there. The first neuron in the layer receives this information. Okay, this is the information provided by my earlier neuron, but I feel that this is not good. Therefore, he shouldn't have given this much of weightage to the cucumber. Reduce that. I have my own choices, my own taste. Therefore, I add something that is called bias. My own bias is added to that, and process it, and correspondingly activates and give that information to the next neuron in the next layer. Similarly, in the second layer, we have a number of such neurons does the same task, receiving the same signal, but the weights may be different. Correspondingly, activation will be different. The output generated and given to the next neuron in the next layer also will be different. Then we come to the third layer. Each neuron in that layer also works the same way, receives the signals, uses the weights, processes it, and gives it. Similarly, does work. Suppose that layer gives some task like identifying the respective the menu created or dish created. Then this is given to the, say, the last layer. There the naming of that particular product is given, say sandwich, which type of sandwich is. Therefore, this is what we could be able to visualize: a deep kitchen where collection of mini chefs working in a very organized fashion, in a layered architecture. Each unit or each mini chef in the first layer working similar way, receives the input, process it, and give the output to the next mini chefs in the next layer. And this happens one after the other, and at the end one could be able to give some output or end dish. And this is what exactly deep learning works. It receives inputs, then each of the neuron receives this input corresponding to the weights, processes it, and gives the output. It doesn't know from where it is coming, originated from, and for what purpose these things are used, but collectively all the neurons in the neural network work in a very, very structured fashion, and at the end the neural network could be able to provide fantastic output. This is the way the deep neural network works. The deep, the word in the network is corresponding to the complex number, big number of layers involved over there. More complex problems could be able to be dealt with large number of layers. Therefore, we have the nomenclature deep neural networks. The learning taking place within this deep neural network is said to be the deep learning. The deep neural networks which we discussed can appear in majorly 3 different formats or types. The first one is called feed-forward neural network. Second is convolutional neural network. And third is recurrent neural network. Here we are in the deep kitchen where we have a number of mini chefs arranged or taking positions at different layers. Therefore, you could be able to visualize them as something like assembly line chefs. A typical responsibility at every instant of time. Therefore, the neural network proceeds or gives a signal in a forward direction. First to second, second to third, third, fourth, etc. There is no moving back, only moving forward. Therefore, such a neural network is said to be feed-forward neural network. Then the question comes, how the feed-forward neural network learns in the process. Here only information is processed from left to right. How the neural network learns? Let us see how it is working. In this case, then the information is passed from left to right, and at the end, on the right side, we will be able to get the end result, that is the sandwich. Suppose the taste of sandwich is checked and that information, that is the loss value, suppose it requires to have a score of 10, suppose it is not that good, it gives only a score of 7. 10 minus 7, that is the loss value. That means there is some mistake, some deficiency, some shortcomings involved in that process, and that loss has to be reduced. Whatever the end product received is gone through different layers. Therefore, each and every neuron which participated in the processing of information and giving the signal to the next one is slightly responsible for these shortcomings. Then this shortcomings of 3 is passed from the output layer to the next previous layer, saying that, guy, this is your responsibility. There is a deficiency of 3 that has to be corrected by you. Whatever the weights over there in the last layer could be able to be updated based on the error, and now the units in the or the neurons in the layer 4 says that, yes, I take the responsibility of whatever shortcomings, but I have just shared whatever I have got from you, the previous layer. I have taken my own responsibility, now you may take your responsibility. Therefore, this information, this shortcomings is propagated backwards from fourth to third, similarly third to second, second to first, etc. Therefore, there are 2 types of movement. First is the feed forward, that is the signals or information is moved from left to right in the feed forward direction. Then on reaching the output, whatever the error, whatever the loss value involved over there, that error value has to be propagated back so that each of the neuron contributed to the generation of the signal will have to be corrected in that weights. And this process of going back and giving responsibility to each of the neuron in each of the layer in a backward direction is said to be back propagation. Therefore, feed forward and back propagation act in a regular usual fashion, one direction providing the signal, the other direction providing the correction to be done. This process of moving the signal from left to right feed forward and right to left in the backward direction for correcting the error is said to be an IPO. Therefore, this is one movement to the left to right and right to left is said to be an IPO. Then we continue the process in the IPO number 2, IPO number 3. Suppose we do this in hundreds and thousands of times, and each of the neuron in the whole network could be able to come with the weight such a way that the signals collected from the input layer and given at the end as the output could be able to match with what is the expected answer. That means the loss value will be very, very negligible and small. And then we could be able to say that the deep neural network has trained. I am a zoom-in chef. I have a peculiar character. Whatever I see, I want to zoom in and understand what is inside. For example, this is a sandwich. I have a magnifying glass. Through that magnifying glass, from moving from left to right, top to bottom, I could be able to use that magnifying glass in order to understand what is inside. And by combining it, I could be able to get a complete idea about what this sandwich is. In addition, whatever the magnifying glass, this is something called an intelligent magnifying glass. For example, I have this as the magnifying glass. I keep it over here on the left top side, allowed to move from left to right. In this process, if there is a tomato inside, and that tomato characteristics could be able to be captured by this magnifying glass. I move from left to right. Wherever the magnifying glass, this tomato picks the respective tomato in the sandwich, and it could be able to capture that information. Thus, moving from left to right, top to bottom, we could be able to get an idea about where exactly such tomato available in this sandwich. Suppose we change this into another one. I want to know how many places cucumber is there, and we allow to pass from left to right, top to bottom, and correspondingly it could be able to figure out. And each of this magnifying glass is said to be a filter in convolutional neural network. By having many different filters which could be able to understand the properties or characteristics of this particular sandwich, by processing all this information captured by filters, and correspondingly it could be able to get an idea about what the object is. This is the exact way our biological neural network works. When you see my face, you may not be seeing my face as a single entity. You may be seeing small curves, small patches, and collectively it brings an idea of eyes, nose, ears, teeth, etc. And combining together, you could be able to see my face. And this idea of biological neural network is incorporated especially for tasks like object detection. This type of convolutional neural network does. Therefore, when any of your intelligent devices captures your face, Google Photos identify yours as well as your friends' photos, and this type of convolutional neural network is used over there. I am a mini chef, not only just a mini chef, but I am a memory chef. I remember 1 year back, you came and asked for a sandwich which is made up of brown bread. You came for the order or a sandwich which should not have cucumber. Yesterday you ordered a sandwich which was grilled sandwich. I remember each of your specific requirement because I have a very strong memory. I am a memory chef. Since you like brown bread, since you don't like cucumber, and since you want the grilled sandwich, I should be in a position to take the order for a sandwich specific to you. That means last 3 occurrences will trigger me or help me to predict what exactly your requirement would be in the next order. And that is what the recurrent neural network does. The recurrent neural network follows the idea of keeping the memory of the previous occurrences. This memory will help us to predict the next outcome much more judiciously, much more effectively. This type of previous occurrences previous experiences and the capacity of the neurons or networks to remember that memory and to play with that memory will help us to have much more effective prediction. This will have lots of applications in anything which involves sequencing, the natural language processing. For example, when I say, how are you? Guess it. How are you? Are you? Are you okay? Therefore, this type of prediction of the next word based on the common occurrences of the previous words will have lots of implications in natural language processing. Here we have the machine learning playground, and here we have the artificial neural network. Therefore, our objective is to separate two different objects using artificial neural network. Remember, when we have many layers, artificial neural network is said to be a deep neural network. Therefore, hardly any difference between deep neural network and artificial neural network. Therefore, suppose here we have some toy problem wherein which we have two sets of observations. This is the one type of observation and this is another type of observation. What is our task? Our task is to separate or classify these two sets of observation. We cannot draw one line and separate because the separation is not that simple. Therefore, let us try with artificial neural network. We use the neural network model here. Then suppose the number of epochs, remember we have discussed the epoch. Epoch is nothing but moving the forward direction, passing the information from left to right, feed forward, and comparing with the actual result. If there is an error, the loss that is propagated backwards and one forward and the propagation of error in the back is said to be epoch or one cycle. Therefore, suppose we choose the cycle to be just 10 over here, and let us see when we allow the neural network to go through this cycles 10 times and see what happens. In this case, we construct the neuron such a way that here we have X and Y, here we have two types of observations. We add layers like this, we add the layers. Here the first layer consists of 4 neurons, second layer consists of 3 neurons, and the third layer consists of 3 neurons, like that. We train the network now, allowed to pass from left to right, feed forward, back propagation, one cycle is over, another feed forward, another back propagation, epoch number 2. This way we do it for 10 times. Therefore, we make it as max epochs to be 10. We train it. Therefore, you could see that there is hardly any change. Remember, we cannot make any separation, everything in a single surface. Suppose we change the number of epochs to be 50. That means left to right, right to left one time. Like this we repeat 50 times. We are training the neural network 50 cycles. See, here we could be able to have much better separation. Here we could be able to convert almost 70-80% data points to two different levels. That means the classification is so good. But still it is not perfect. That means we are on the right track. It says that we need to train the network more number of iterations or cycles. Suppose we change the maximum epochs to be 100. We train it again. See, it has improved substantially. And you could see the surface separating these two types of data points in a very nice fashion. It's carved out that particular separating surface. Still, a couple of misclassifications there. We try to classify that by increasing the epoch size to be 200. Yes, it is better now. As we increase the epoch size, the corresponding segregation surface is far better now. Now we make it to 300 and see whether it is improving. Yes, it has improved and the surface has changed to accommodate more data points to separate one from the other one. Let us we convert this into 500 and see. Yes, it is almost very nicely it could be able to do it. Therefore, we could see that by around 500 these epochs, 500 these cycles or 500 levels of training, the neural network could be able to separate the data points. Therefore, let us make it to 1000 and see any dramatic change happening. No. That means just beyond a level, just by increasing with the same data set, the model will not be taking it. In fact, tries to remember it. That is nothing but overfitting that we need to avoid. Therefore, in this way, we could be able to train a neural network to separate data items, and this way we could be able to make the neural network to make it better. This is what is called feed-forward back-propagation neural network. Now we are here with the sandwich created not by me but an army of mini chefs called neurons. Hope that you have enjoyed the concept of deep learning through mini chefs. If you like this, please like, share and subscribe. Thank you for watching. Please join us for the next video. Till then, truly AI.